Okay, so let's consider this one here, integral 0 to infinity of sine x dx. So we would set it up the normal way. Limit as b goes to infinity. First of all, sine x is defined over that whole integral, so it's no problem. So we go ahead and do our integral. Sine when integrated is negative. So that would be negative cosine x, evaluated between 0 and b. And we have limit as b goes to infinity. Evaluate that. That would be negative cosine b minus the negative cosine of 0, so that would just be plus cosine of 0. See, this presents a problem here, because unlike some of my other things, as the limit as b goes to infinity, this cosine b does not settle onto anything, right? In fact, as you just keep taking on values, cosine just keeps cycling through forever and ever and ever. And so, yuck or ugh, right? That's a problem, right? And because that thing just continues to cycle forever and ever and ever and never will actually settle on an individual value, right? The cosine graph just continues to cycle forever and ever and ever, right? Because of that, right? Continued cycling forever and ever and ever, right? Continuing to bounce back and forth just between -1 and -1 forever, right? Because that's happening, right? This cosine never settles into anything. This cosine of b limit is not going to actually approach a number like some of our other ones did. And so for that reason, this thing is never going to converge. Right? It's never going to converge. It's just never going to happen. Okay? It's never going to happen. So therefore, it doesn't converge. And so that's it for that one. Let's look at another one here. It's a little, even a little bit more to it. So let's look at the integral from 9 to infinity of 1 over the square root of x. 1 over the square root of x dx. Okay. So to work this out, I'm going to write it first as limit as b goes to infinity. Integral 9 to b. X to the -1/2 dx. Okay, so we do our antiderivative. Limit as b goes to infinity. Add 1 to the exponent, which will make it x to the 1/2. We divide by 1/2. That would be 2x to the 1/2, or 2 squared of x. And that's evaluated between 9 and b. Okay, so simplifying, limit as b goes to infinity of 2 square root of b minus 2 times square root of 9. Okay. Now as b goes to infinity, though, 2 times the square root of b is also going to go to infinity. So this is an integral that's going to go to infinity, and therefore it diverges. It does not converge to a single value. It does not converge to a single value. Okay.